Hey everybody and welcome back. In this physics video, we'll be focusing on an introduction of potential energy. In another video, I talked about kinetic energy, and that meant if an object was moving at some speed, it had kinetic energy. So, what makes potential different from kinetic energy? Let's start with this definition. Potential energy is defined as the energy associated with an object because of the position, shape, or condition of the object. So an object has potential energy due to position, shape, and condition. But what does that mean? Talking about position, shape, and condition would be clearer if we actually mentioned the types of potential energy. The ones that we will focus on in this lesson are gravitational potential energy and elastic potential energy. So let's talk about gravitational potential energy first. How does someone or something have gravitational potential energy? First of all, mass must be involved. Second, gravity must be present, as the term suggests, and we'll keep it in the context of Earth with a value of 9.8 meters per second squared. Lastly, let's talk about that earlier detail, position, and how it affects the gravitational potential energy. When we talk about position in reference to gravitational potential energy, we're actually referring to the height. If we want to increase the potential energy of an object, the height has to increase. Likewise, if the object falls lowering its height, its gravitational potential energy decreases. Let's go to the definition. Gravitational potential energy is the potential energy stored in the gravitational fields of interacting bodies. Since it's about how high an object is located, it also depends on where you designate the ground or zero height. Here's the formula for potential energy. Potential energy equals mass times gravity times height. Let's move on to an example. What is the potential energy of a 10.0 kilogram sign hanging on a 20.0 meter building? Let's start by identifying what we know. The mass is 10.0 kilograms, the height is 20.0 meters, and gravity is 9.8 meters per second squared. We have everything we need to solve for the potential energy, so let's plug it in. Multiplying 10.0 kilograms, 9.8 meters per second squared, and 20.0 meters, we get a potential energy of 1,960 joules. Elastic potential energy has to do with springs, bungee cords, rubber bands, anything that can compress or stretch, which focuses on the details of condition and shape. How does an object have elastic potential energy? If the object is attached to a spring, it can have energy depending on how much the spring is compressed or stretched. Second, it depends on something called the spring constant, how strong or weak the spring is. Let's go to the definition. Elastic potential energy is the energy available for use when a deformed elastic object returns to its original configuration. Here's the formula for elastic potential energy. Potential energy elastic equals 1/2 times the spring constant times x squared. X stands for how much a spring is compressed or stretched. Let's do an example. A metal spring is 0.5 meters and compressed to 0.3 meters. If the spring constant of a metal spring is 50 Newton per meter, what is the potential energy? We know the spring was compressed from 0.5 meters to 0.3 meters, and we can solve for x by subtracting the original length from the new length. The spring constant is 50 Newton per meter. With all the information, we can solve for the elastic potential energy by multiplying 1/2 by the spring constant of 50 Newton per meter and 0.2 meters raised to the second power. The elastic potential energy comes out to 1 joule. Okay, so that concludes our brief introduction on potential energy. Hope you found it helpful, and thanks for watching.